Welcome to this explainer. Look, if you've been following the massive explosion of generative AI and large language models recently, you already know that vector databases are, quite frankly, the absolute backbone of the modern tech stack. But today we're looking at a tool that's fundamentally challenging everything we thought we knew about how these databases actually need to operate. Let's unpack Alibaba's Zvec.
So let's just dive right into the big question. Do you really need massive, complicated, server-heavy setups just to handle your vector search needs? I mean, for the longest time, the industry standard has basically been to deploy standalone infrastructure. You spin up a cluster, you manage network latency, configure these endlessly complex endpoints, and suddenly your simple AI feature has turned into a total DevOps nightmare. We've kind of just accepted that vector search equals heavy infrastructure. But honestly, does it have to be that way?
Well, the answer is a resounding no. Zvec is taking a completely different approach. It's an open source in-process solution, and in-process is absolutely the magic word here. It means this database embeds directly into your application. There are no external servers to ping over a network. It lives right there, right where your code lives, giving you battle-tested, low-latency similarity search with virtually zero setup friction. It's a real game changer.
To give you an idea of where we're headed in this explainer, we've got a solid roadmap. We'll properly meet Zvec, check out its blazing fast features, unpack the massive version 0.5.0 upgrades, and finally, look at how it fits seamlessly into your specific ecosystem. Let's get to it!
All right, Section 1. Let's officially meet Zvec, your new local serverless solution.
Usually, when we think of databases, our standard expectations involve dedicated servers, juggling network protocols, and just endless YAML configurations, right? But Zvec's reality is a pure local experience. You just install it like any standard software package, and it simply works. There are no servers to maintain, no complicated network layers to untangle, literally no fuss. You get all your vector search capabilities instantly, securely, and completely locally. Now, when you hear words like lightweight and Python, you might naturally assume, okay, they're probably sacrificing speed. But that's where Zvec really surprises you. Under the hood, it is overwhelmingly driven by C++. We're talking over 80% of its code base. That is a brilliant engineering choice. By relying so heavily on C++, Zvec guarantees production-grade, ultra-low latency. So you're getting raw, bare metal performance, but wrapped up in this incredibly accessible, easy-to-use package. Moving on to Section 2, let's talk about those blazing fast features, getting production-grade power without all that heavy overhead. Here is the absolutely crucial takeaway. Zvec scales seamlessly. Even though it's a local, in-process library, please don't mistake it for just a prototyping toy. It can search billions, yes, billions with a B, of vectors in mere milliseconds. It's wildly flexible too, supporting both dense and sparse embeddings so you aren't boxed into one specific type of math. And it's incredibly smart about concurrency. Multiple processes can read the exact same collection simultaneously, while writes stay exclusive to a single process to keep your data perfectly safe. And because it just lives inside your process, it runs literally anywhere your code runs. A Jupyter notebook, a massive production server, a simple command line tool, or even a tiny edge device. It just goes wherever you go. Which brings us to something absolutely vital if you're building for the enterprise: durability. Look, local definitely does not mean fragile here. Zvec uses write-ahead logging, or WAL. It's a classic, rock-solid database technique that ensures every single change is logged before it ever hits the actual database itself. Basically, it guarantees persistence. So even if your app crashes spectacularly or someone physically trips over the server power cord, your vector data is completely safe and recoverable. No lost data, no panic attacks. All right, on to Section 3. We need to unpack the version 0.5.0 upgrades. This was a massive release that dropped on June 12, 2026. This update was a huge leap forward. First up, full-text search. You can now natively attach an index to any string field. That means you don't have to bolt on some clunky external search engine anymore. They also brought in hybrid retrieval, which is amazing. It lets you run a single multi-query that perfectly fuses dense vector similarity, sparse vectors, scalar filters, and full-text search all at the same time for incredibly precise results. Oh, and the new DiskANN index? It drastically cuts down your memory overhead by keeping the bulk of the index safely parked right on your disk. Brilliant stuff. And that brings us to Section 4, built for your ecosystem. Let's look at the SDKs and tools that make this so incredibly accessible. Honestly, getting this up and running is refreshingly simple. Step 1. You just grab the official SDK for whatever language you're already coding in. Boom, it installs in seconds. Step 2. If you're a visual person, you can fire up Zvec Studio right away. It's this great tool that lets you visually browse your database collections, inspect your vectors, and debug really complex queries without writing a single line of code. It completely demystifies the data you're playing with.
And speaking of languages, it fits right into your workflow. Whether you're using Python 3.10 through 3.14, Node.js for your backend, or you need those lightning-fast Go or Rust bindings, Zvec has your back. They even have official support for Dart and Flutter if you're building mobile apps. And of course, cross-platform compatibility is just a given here. It natively supports Linux, macOS, including ARM64 architecture, and Windows. They've pretty much thought of everything.
Now, if you're sitting there wondering, okay, but can I actually trust this in production? Just look at the social proof. Over 10.8K GitHub stars. It's open source, highly maintained, and is battle-tested inside the massive infrastructure of Alibaba Group itself. The developer community is rallying around this tool for a very good reason. It elegantly solves a very real, very painful problem.
Ultimately, this explainer highlights how Zvec just completely removes the friction of complex database setups. By collapsing all that heavy infrastructure down into a lightweight, in-process C++-powered library, it frees you up. You can focus entirely on your application's core logic instead of playing DevOps. It brings incredibly scalable, lightning-fast vector search directly into your local environment. So it really leaves us with one final exciting question. With a tool this powerful right at your fingertips, what intelligent application are you going to build next?